This is the third embodiment of the wireless Tesla coil. The first embodiment we procured 110 volts to go to the arc gap. Second embodiment we procured 200 volts to go to the arc gap. And this embodiment we got almost 300 volts going into the arc gap. We're not going to show that Tesla coil today. We're going to show instead the lighting of a helium bulb. And what we've done now on the second embodiment, we've added a coil underneath 266 primaries. We have ripped everything apart. Everything has been ripped apart. And we want to quickly note and shut this off and go back into the what we're doing here. Formerly, when we first started exploring these effects, the amperage meters were attached between two Delta series resonances and with an amp meter between the L and C quantities. We assumed that shorting out them quantities would deliver the same effect as if those quantities were not there. This is not entirely true, and idiosyncrasies evolved from that. From there then, what we've done is we've completely disengaged that middle process, and we've ripped everything apart. Now there's all the wires that we've taken out. More importantly, now we want to look at what are our inputs and what does it mean. The back 3 meters are the delivery lines, 0.27, 0.19, 0.30. The yellow meters in front are our voltages. We have 0.9 volts on phase 1. We have 1.3 volts on phase 2. And we have 0.8 volts on phase 3. Our secondary amperage meters there show the delivery of amperage on each phase. Now, what we've done is we've taken the middleman out of the picture. This stuff's no longer even hooked to the circuit. We'll go and turn the process. We've shown here what our inputs are at this point in time with an unenergized field. And with this inputs, we are now obtaining close to 300 volts. The way we obtain this extra voltage is we put an extra secondary underneath the 266 primary. Now what we want to do is go in and show. I'm going to turn things off for a second. Process of ripping everything apart then. The previous videos we really couldn't see what's going on. The alternator. And that alternator has 3 stator line delivery wires. Should be able to see 2 of them, 3 of them. Long guy. There's 2 white ones, and there's a red one underneath of it. There's the 3rd red one going down. These 3 wires all come down to 3 meter leads, and those give us our supply lines. And those are the top 3 meters. And then from there, each of them meters, the end lead of them meters, coming out to a probe, goes to the actual delivery amperage line. Okay, I think that's pretty well self-explanatory. And so now we need to turn the process back on. The yellow meters are the voltage meters, and we need to show the effects of both the top loading and the bottom loading. The effects on the top loading are totally different from the bottom loading. On the top loading, when we place that coil on there, it reduces the amperage on that third top layer. On the bottom layer, when we add that load from the coil underneath, it enhances that amperage. The two processes work differently. And now we have to consider then, and we go back in there and turn this on, we want to look, I'm going to raise the top coil up, and we're going to change right now. We've seen that it's almost 300 volts. We're going to just record the voltage on the top layer. So we're going to go just what the capacity on the top layer is delivering voltage wise. We'll go ahead and turn this on again. Voltage being received from the top layer is 210 volts. And now what we're going to do is we're going to watch what happens when I remove the top coil from the 266 primary. Unfortunately, we also have to observe the amperage considerations. We'll do that real quick. 211 volts. Now we're going to look on the layers, their amperages themselves. We're going to do the same thing. And we want to be focused on the meter reading 0.14 in fluctuation, 0.14 amp in fluctuation. That is the amperage going through that top layer. Go to the top layer, it's up. Place the top layer now. Now we're going to do the same thing with the bottom layer. We're going to lift that whole assembly up. And first we need to change our voltage meter for the approximate 100 volts that bottom secondary is receiving. See that we got 122 volts coming off the bottom layer. Each of these layers have 50 nanofarads of high voltage capacity. Now, in order to show this demo, then we're going to back out of here. So to keep an idea on that voltage meter, showing 122 volts. Now we're going to pick up the entire assembly off the bottom secondary. Now we put it back. We're going to repeat the observation with their amperages concerned. And the bottom layer, try to get all three amperage meters in there. The bottom layer is now currently consuming 0.227 around in there in its cyclic activity. And once again, we're going to pick up the entire assembly off of that secondary. We're going to note the amperage changes involved. The amperage increases in that instant, or like an ordinary ferromagnetic transfer. Now that we've demonstrated these two things, we're going to show the lighting of a helium bulb by the process, and we'll note that the amperages involved produce the voltage. Bottom secondaries, there's 33 milliamps on the top secondary, and there's 18.9 milliamps or 18.6 and thereabouts on the bottom secondary. Each of these milliamps are equivalent to 6 volts. So we can say then that the top one, 33 times 6 gives us an approximate idea of the voltage on the top, and 18.8 there gives us an approximate idea of the voltage on the bottom. We've already seen that they combine roughly 100 and 200 volts combined into approximately 300 volts. Now we're going to take the voltage meter out of the picture, because when we go in there and start lighting our helium bulb, we're going to find that we don't want a voltage meter in there. See, 700 some volts, but we can deduce what that voltage will be by our consumptions of secondary amperages. Now we'll quickly, there is our helium bulb. We'll back out the picture here. Go in there and turn the field up. The field has not yet been energized. With the 5 volt field, that's with the 5 volt field. We'll turn our halide up. That's with the 5 volt field. Rapidly running out of time. There's our inputs. It's like about 6, 9, and 6 volts on 3 phases. There's our delivery line amperages, and here is our amperages on that delivery line. We can't really see that, but I'll note that it's 68 milliamps on the left and 81 milliamps to the other side, and that should give us an idea of how much energy it's requiring from our source to produce this effect. Thank you.